All right, so we're going to start our new unit on trigonometry. The first lesson that we're going to talk about today is right triangle trigonometry. So the stuff we talk about today only applies to right triangles. So make sure that you're only using this when you see a right triangle. So first of all, there are 3 buttons on your calculator. We have sine, cosine, and tangent. You guys should be familiar with those buttons from past years. They help us solve for missing angle measures and side lengths in right triangles. So you always want to make sure your calculator is in degree. So go to mode and make sure degree is highlighted. So make sure degree is highlighted in your mode. Okay? So example 1, all you're doing here is you're just going to type it in directly in your calculator just like you would doing basic addition and subtraction. So on your main screen of your calculator, you're going to press sine buttons right here, sine 78, enter. Again, make sure, see I'm in rating, I need to be in degrees. So sine 78, and that is 0.9781. Always round to 4 places. Okay, you can do cosine, so say the same thing. So cosine of 78 is 0.2079. And then we'll use tangent. Tangent of 78 gives us 4.7046. Okay? So now you go ahead and try. Pause the video for a second. Go ahead and try out your the U-try and see what you can do. All right. So you should have discovered that the cosine of cosine of 45 degrees is 0.7071. The sine is the same, and then tangent would be 1. Okay. So now let's talk about what these functions mean. So when you guys might remember that back in Math 2 we talked about SOHCAHTOA. SOHCAHTOA. If you don't remember what that means sine is opposite over hypotenuse. So sine of theta, which is your angle measure, equals opposite over hypotenuse. Okay. It also means that cosine equals adjacent over hypotenuse. So cosine is adjacent over hypotenuse. And then tangent is opposite over adjacent. So tangent is the opposite over the adjacent. Okay, so that's the general definition of sine, cosine, and tangent. What you didn't learn last year, though, is these are their reverses. So if sine is opposite over hypotenuse, cosine is hypotenuse over the opposite. So it's the flip of it, or the reciprocal. Secant would be the hypotenuse over the adjacent. And then cotangent is adjacent over opposite. And these are just the reverse of the ones beside them. So the reverse of sine would be cosecant, the reverse of cosine would be secant, the reverse of tangent would be cotangent. So looking at a triangle, like over here, here's my angle. Okay, that's marked theta, this is called. Okay. So from this angle, the side that's across from the angle is your opposite. The side that is beside it is your adjacent. And then your hypotenuse is always across from the right angle. That's how you determine. So let me just draw a random triangle here. So if I picked this to be my angle, that's my theta for this one, right? Okay. Opposite would be across from it. Adjacent would be a side beside it. And hypotenuse will be the across from the right angle. So from this angle, you have opposite, adjacent, hypotenuse. Okay? So let's look at example 2. All right, so find the indicated trigonometric ratio as a fraction and as a decimal round to the nearest tenth. So let's look at, we're just going to do it as fractions for right now. So sine. Sine is opposite over hypotenuse. So from m, that's what we're looking at, m, right? Our opposite would be 16. Our hypotenuse would be 34. So 16 over 34, which reduces to 8 over 17. So the sine of m, when reduced down, would be 8 over 17. Okay? Let's look at the tangent of L. L is here. Tangent is opposite over adjacent. So L, opposite would be 30, adjacent would be 16. So opposite is 30, adjacent is 16. So it's going to be 15 over 8 when you reduce it. Okay? Cosine of L, cosine is adjacent over hypotenuse. So adjacent 16, hypotenuse 34. So 16 over 34, which reduces to 8 over 17. All right, so we have the cosecant. Cosecant is hypotenuse over opposite. And we're looking at z. So hypotenuse is 20, opposite is 16. So this is 20 over 16, which reduces to 10 over 8, which is 5 over 4. Okay, these are fairly easy. Just find your angle. X is here. The secant is hypotenuse over adjacent. So from X, hypotenuse is 20, adjacent is 16, which also reduces to 5/4. Okay. Cotangent is adjacent over hypotenuse, or adjacent over opposite, I'm sorry. Adjacent over opposite. And from Z, adjacent would be 12, opposite would be 16, so 12 over 16, which is 3/4. Okay, so that's all you have to do there. You're just looking at for the ratios, and we're not going to worry about decimal rounded to the nearest 10,000th right now. We're just going to look at the fraction. All right, so solve the following triangle. So let's look here. We're going to make theta the angle right here. Okay. We know the secant is 5/4. Well, the secant, if you look up here, secant is hypotenuse over adjacent. So this is hypotenuse over adjacent. So from this angle, we know the hypotenuse is 5 and the adjacent is 4, right? And do you know how to find the third side of a right triangle? What do we use to solve for a side of a right triangle? We use Pythagorean's theorem, so we say a squared plus b squared equals c squared, right? So we know that 16 plus a squared equals 25. Subtract over our 16 and we get a squared equals 9. So a equals 3. So this is 3. Now that we have that, sine is opposite over hypotenuse. Cosine, well, even if you didn't have this, the cosine is the inverse of the secant. So it's going to be 4/5. But cosine is also adjacent over hypotenuse. Adjacent over hypotenuse. Tangent is opposite over adjacent. Opposite over adjacent, so 3/4. And if you look here, you can just go from here to here now. So reverse this one, 5/3. We got this one. Reverse this one, 4/3. Okay, so go ahead and flip, sorry, the announcement came on. Go ahead and flip your paper over to the back, and let's look at inverse functions. Inverse functions are how do you find an angle of a triangle? So if we know that cosine of A is 0.7431, right? To get rid of the cosine, so we're trying to get A by itself. So we got to get rid of this cosine. Well, if you look on your calculator, let me zoom in a little bit here. If you look on your calculator, see how it says cosine -1 up here, or sine -1, or tangent -1. Those are called the arc trig functions, and we call them inverse trig functions also. So what you would do is you would take the inverse cosine, so let me zoom back out here.